Download this code from codegive.com, link in the description below. Certainly. The backpropagation algorithm is a fundamental concept in machine learning, particularly in training artificial neural networks. It allows the network to adjust its weights based on the error of its predictions, ultimately improving its accuracy. Part 1: Understanding backpropagation. What is backpropagation? Backpropagation is a supervised learning algorithm used for training artificial neural networks. It is based on the chain rule of calculus and allows the computation of gradients of the loss function with respect to the weights of the network. The algorithm consists of two main phases. One, forward pass: the input is passed through the network, producing an output. The loss, error, is then calculated based on the difference between the predicted output and the actual target. 2, backward pass: the algorithm calculates the gradient of the loss function with respect to each weight by applying the chain rule. These gradients are then used to update the weights in the opposite direction of the gradient, minimizing the loss. The structure of a neural network. A typical neural network consists of input layer, the layer that receives input data. Hidden layers, intermediate layers that process inputs. Output layer, the layer that produces the final output. Each layer consists of neurons, nodes, which use activation functions to introduce nonlinearity. Activation functions. Common activation functions include sigmoid, outputs values between 0 and 1. ReLU, rectified linear unit, outputs the input directly if positive, otherwise, it outputs 0. 10, outputs values between -1 and 1. Example, implementing backpropagation from scratch. In this example, we'll create a simple neural network with one hidden layer to perform binary classification using the backpropagation algorithm. Step 1, import necessary libraries. Step 2, define the neural network. We'll define a simple neural network structure. Input layer, 2 neurons, for 2 features. Hidden layer, 2 neurons. Output layer, 1 neuron. Step 3, forward pass. The forward pass calculates the output of the network. Step 4, backward pass. The backward pass calculates the gradients and updates the weights. Step 5, training the neural network. Now that we have defined our neural network structure, we can train it using a dataset. Step 6, putting it all together. Here's how you can create an instance of the neural network and train it on a simple dataset. Summary. In this part of the tutorial, we covered the basics of the backpropagation algorithm and implemented a simple neural network from scratch. We defined the structure of the network, performed forward and backward passes, and trained the network using a sample dataset, the XOR problem. In the next part, we could explore more complex architectures, different activation functions, optimization techniques, and using libraries like TensorFlow or PyTorch for more efficient implementations. Feel free to ask if you want to dive deeper into any specific aspect.